Introductory Statistics, the 10th edition. The author is Mann, so that is what we'll be using for this class. So I'll follow the textbook very closely. And so let's start with chapter 1. So that is about some introduction about statistics, and then the definition for statistics can be seen on the screen here. So we know what is statistics. It's collecting and also organizing, analyzing, and also interpreting data. The data could either be numerical or non-numerical, and then that would help us provide useful information about the topic. So statistics is very, very, very important in real life. It helps us to be able to make useful decisions, and also help us to make future predictions or also forecast. Now let's look at an example. Suppose that with the help of statistics, suppose that the government wants to provide relief for people who are low income earners. How can the government be able to implement such program? The government can be able to do that with the help of what? Statistics. So statisticians can decide to take the income data of people and also their geographical locations, and then with the help of statistics, the researchers can be able to analyze this data, and then they will be able to tell that, okay, well, maybe people living in this part of United States are maybe low income earners. The other people living in, say, maybe the likes of California and co are high income earners. So then this would help the government to be able to apportion the relief funds to the target individuals or people. So this makes statistics very, very important. So then it's going to help the government to be able to make useful decisions. And also, just like COVID came, we were able to see the importance of statistics with regards to the COVID that hit the world. So with the help of statistics, we were able to see whether the cases were dropping or were increasing exponentially with time. And so the government was able to also see which states were recording high cases with the help of graphs and other useful tools. And also that also helped the government to be able to make decisions like implementing lockdowns, which parts of the world need to ease restrictions. And so this and many other examples shows you why statistics is very, very important in real life. Now, there are two types of statistics. We have the descriptive statistics here, and then also there is also the inferential statistics. And so the descriptive statistics, it consists of method of organizing and also summarizing information such as graphs, table, charts, and then also we could also compute the mean, the mode, the median, and then the range. For example, when the COVID came, you could see that there were states that were reporting that maybe the average daily cases maybe in New York is this number. So they were able to tell that with the help of statistics, with the help of the data that they gathered. And so presenting those information on graphs, on pie charts, histograms, and other visual representations. So such is called the descriptive statistics. And then we also have the inferential statistics. So with the inferential statistics, it's not every time that we could be able to get all the data about the population. So in such situations, we tend to make conclusion for the whole population based on the sample, and so such is called the inferential statistics. An example is, for example, if we want to see the lifespan of, say, grass cutters, maybe living in maybe a number of grass cutters living in, say, maybe Tanzania, or want to see the lifespan of lions living in Tanzania or Senegal. It's very difficult to be able to observe all the lions in Senegal or in Tanzania or in any other part of the world. And so because in reality we cannot tell the number of lions living in these parts of the world, and so we could be able to make such conclusions, or we could be able to make such inference based on some sample of lions we could be able to get, and then we would observe them, and then we could say that, oh well, the average lifespan of a lion is maybe 80 years or maybe 70 years. So that is what inferential statistics is. And this is also very useful because sometimes it is also very maybe practically impossible to get the whole population, or sometimes it's also very expensive. Let's say that you want to find the average income of people living in China, or the average income of people living in India. These big countries have huge population, and so it's going to be very expensive to be able to conduct a census on everybody. And so you could be able to save cost and also utilize inferential statistics. And so then this takes us to what I want to talk next about the difference between a population and also a sample. So a population consists of all individuals or items under consideration in a statistical study, and usually the population size is denoted by n. So when you look at this visual stuff here, so assuming that this is my population, and then a sample is a representative of the population. So when you look at this chart here, so let's assume that this is the population, which means that everybody here, and then the sample is what? I'm going to choose some items or individuals from the population. So I try to pick these people here. So then this guy here, this guy there, and also this guy here. And so then this is what we call the sample. So the sample is usually a subset or part of the population. And then also, I also want us to also understand what an element is. An element is a single member of the population. And also, how do we obtain information? Like we did say, we could obtain information by conducting a population census. We could do a census. We could also do sampling, and then we could also do experimentation. So for example, sampling, for example, this is like sampling, like choosing some elements of the population for your study. And then for the census, it's considering all the elements in the population. And also for the experimentation, you remember when the COVID came, how were they able to say that this vaccine is effective, or sometimes when there is a disease, how are they able to say that, well, this medicine is 90% effective or 100% effective? So they apply what we call experimentation, whereby they try to observe some people, and then they try to give them those drugs, and then observe how they are going to react to those drugs, and how effective are those drugs. So that is what we call the experimentation. And then I also want to talk about the sampling design. So the sampling design is a methodology of choosing elements from a population to form a sample. So for example, this is also a sampling design. How did I decide to choose this guy, this guy, this guy, and then this guy? This guy here, this guy, and then this guy. So the process of choosing such people is what we call the sampling design. So we want to talk about a few of them. We have what we call the simple random sampling. So for the simple random sampling, what it meant is that, for example, if all the items here are maybe, let's say maybe they are 15, I don't know the number, but let's say they are 15, and then I want to choose maybe 5 people out of this 15 elements here. What simple random sampling means is that each of the elements have an equal chance of being selected. Each of the elements here have an equal chance of being selected. And so it means that I could either choose this guy or this guy. Each of them have equal chance of being selected. That is what the simple random sampling means. It means that the process of you choosing any of them is random, and then they all have equal chance of being selected. And then I also want to talk about, there are 2 types of simple random sampling. There is one we call the sampling with replacement, and the other one is sampling without replacement. So let's talk about the simple random sampling with replacement. What the simple random sampling with replacement means is that, for example, I have this, maybe the population here, let me add a couple of them. So I have 1, 2, 3, 4, 5, 6, 7, 8. And then simple random sampling with replacement. Let's say that I want to choose maybe 3. I want to choose 3 out of the 8 here to form the sample. So with the replacement, it means that if I decide to choose this guy here, so if I choose this guy, with the replacement means that I'll put that guy back again and choose. Does it make sense? And then, so I'll do that for 3, which means that each individual has the chance of being, there's a chance that you could choose an individual twice. That is what the simple random sampling with replacement means. And then the simple random without replacement means that, for example, if I choose this guy, it means that this guy is no more. If I decide to also choose this guy here, it means that then this guy will be no more. So that is what the simple random sampling without replacement means. So I'd like to end here, and then we'll continue tomorrow.